Hello everybody. Welcome to the session on building fast web UIs with React. Before we get started, just like to take a quick survey. How many folks are already using React? Anybody? A couple of people. You probably don't need to be in this session. So this is a very basic introduction to React, and if you're already building stuff with it, you probably would want to go to another session and not waste your time here. But for the rest of you, what we're going to do is we're going to talk about React. React is a UI-only library. So when we think of client-side MVC, React is only the V in that. It's only the view part of it. So you don't get models, you don't get controllers, other things like that. But it was developed at Facebook, and it's the engine that powers essentially their web UI for Instagram.com. Okay? So let's cover some basic React concepts first, and then we'll get into some code and have a look at our demo application. Actually, while we're here, this is the demo app. Does that look okay on the screen? Yeah. So you can see it's essentially just a Twitter feed that we're pulling down from the Twitter API, and we get this nice little thing here that says there are 42 new tweets mentioning DevOps. And then when I click that, it essentially refreshes the view. But you saw how quick that was. It instantly inserted those 40 new Twitter mentions or whatever directly into the view. Right? So you can see I hit that again, and it just pops in very, very quickly. And if I scroll down, you see that the infinite scroll here loads up those next 50 tweets very, very quickly. Right? And this is what we're interested in with React, because it allows us to build very performant user interfaces. Right? One of the key things about React is that it's what we call an isomorphic framework. Now, how many folks have not heard of the term isomorphic? Okay, so a fair number. We'll spend a little bit of time talking about that. Isomorphic basically means that when you write JavaScript code, it can run either on the browser or on the server. Right? We're going to look at an example of that in a few minutes. But this is essentially how to visually think about isomorphicity. Right? You have JavaScript code that can run on Node.js, and you have browser JavaScript, obviously. And when you program in an isomorphic library like React, your code essentially is somewhere in the middle part that overlaps the two. Right? And the reason why isomorphic apps are kind of the wave of the future, and there's a lot of buzz about them, is because it allows for great flexibility and performance management. Right? As we build more complex user interfaces in the web, we need to have a way to be able to better manage the performance and other small things to make a really nice front-end application. Right? But the isomorphic nature of React is not the main reason why it's fast. There are actually a couple of other things that React does that make it run really fast compared to other solutions. Right? The first one is that it has this concept of a virtual DOM. And we'll talk about that in more detail in a few minutes. But it also does, because it has this virtual DOM, it can do interesting things like smart diffing of the UI state, smart diffing of the DOM that you currently have in the web browser and the DOM that you want to push into the web browser, right? And another thing you can do with this virtual DOM is it allows you to do batch DOM updates. So instead of doing one-by-one changing of the DOM, it can do a batch update and update the DOM once. And there's a reason why that is very helpful in terms of performance. So when we look at a typical browser update, this is what it looks like. Okay, what you have is first you have to parse the markup in CSS, then the browser has to create a render tree, and then has to do a reflow and repaint, right? So all these things take time, and especially the last one is very heavy in terms of the browser's performance. So if you do a reflow and repaint a lot, you're going to get a slow experience in the web browser. This is the main problem, right? Obviously, there are other things that happen before this that also take up CPU cycles, but the main one is doing the reflow and repaint in terms of how much it impacts the browser's speed. Right? And what triggers a reflow and repaint? Actually, there are a lot of things that trigger it. Any DOM update triggers a reflow and repaint. Hiding a DOM node. Doing any kind of move or animation in the DOM. Style changes. Okay? There's a bunch of other things, but these are the main ones that you're probably familiar with in terms of what causes a reflow and repaint, i.e. what causes your client-side JavaScript web app to run slowly. All right, so again, the virtual DOM is essentially something that mirrors the DOM that is actually alive in the browser. So that's where your state is kept. Okay? And what React does is it essentially mirrors that in JavaScript objects. So you essentially have a snapshot copy of the data that's in the DOM in JavaScript objects. You don't really interact with these directly. React kind of gives you a little bit of an abstraction layer on top of that. All right, so the next thing is, we talked about the smart diffing of the DOM. This one is obvious, right? If we look at the virtual DOM and we look at the DOM that's actually in the browser and we compare the two, we can say, oh, only these things need to be changed. We don't need to change all these other things, right? And again, this is something that is abstracted away for you in React.js. Finally, this one is pretty important. By using batch DOM updates, we're able to reduce the number of reflows and repaints we have to push into the browser. So it makes the user's experience much, much nicer. All right. So let's get into some React basics now that we've covered some of the fundamental concepts in React. And the first one is that React is a component-based library. And again, remember that React is it's just the view layer. There's no controller, there's no models, anything like that. So a typical question at this point is, well, what if I need those things? What do I do? Well, you can actually use React with other libraries. So if you're using Backbone, you can use React as the view layer in Backbone. Or if you're even using Angular, you can use React as the view layer in AngularJS. Okay? So there are several libraries. If you go and Google search this, you'll find that there are several libraries out there which allow you to glue in React into, say you're using Backbone or you're already using Angular. You can start using React in a small way and then eventually take the entire view layer into React. So you can do it piecemeal if you want to as well. Okay. Just out of curiosity, how many people are using Angular? Wow. Okay. Backbone? Okay. Anyone using Batman.js? I'm just kidding. I just wanted to see if anyone uses any of these esoteric frameworks. So it looks like the majority of the folks in this room use Angular. And like I said, it is possible to use Angular and React together. There's some nice little glue libraries that people have put together to allow you to use React inside of Angular and get all of the things we've just talked about. All right. So let's look at a React component very quickly. Right, so what we do is we have a couple of things going on here. First thing is on the first line where it says script type equals text/JSX, you can see that we've introduced a new type, or essentially a new script type here. And then immediately below it, there's this / ** @JSX React.dom. Right, so what this does is when you have this script tag with this React JSX, and we'll talk a little bit more about JSX in just a second, the React part of the library that runs in the browser recognizes this, let's call it an annotation. Okay, it recognizes this marker, and from here you know, or the React library knows that we're going to be writing the rest of this code in what's called JSX. So if we look at this, you'll see that we have React.renderComponent, and then you can see there's just a H1 with the hello world in there. And then after that, we have a document.getElementById, i.e. that's a node in our web application, right, called mydiv. Right, so this is a very basic way of creating a component. This component obviously is not very interesting, but if we look at what JSX is HTML-like. It's not exactly like HTML. Right? So if we go back to this example, you'll see that there's, we've just inserted some plain HTML, but there are some small nuances in terms of how JSX differs from HTML. And if you go to the URL that's in the last bullet on this slide deck, you can see what those differences are. And they're not huge differences. They're small differences that you need to be aware of as you're programming in JSX. Okay? Again, it's HTML-like. It's not HTML. But for me, when I like to do views in the client, I don't generally like to use HTML because, I'm a programmer, right? I don't do text or markup or stuff. I prefer to write code if possible. So the great thing is in React, you're not limited to just using JSX. You can actually write your components using what we have on this screen. So you can see, again, we have React.renderComponent, and the second argument here, the last line, is where are we going to put this specific component into the UI. But if you look at the second line, react.dom.h1, you see that we're creating an h1. This is equivalent to what we created in the previous slide, but instead of using markup, what we're doing is we're just using their specific API, the React-specific DOM API for creating DOM elements programmatically without HTML. Okay, and I think this is very nice. Obviously, there's a lot more parameters that we could pass into this, but just as a simple example, you get the idea of what you can do here. Okay? One of the reasons I prefer this in some ways to doing straight JSX is that because this is just straight JavaScript, it allows me to test these components I create. It gives you more flexibility in terms of how I test it, right? So I can wrap a function around this using some functional programming techniques and insert the mock or insert a spy or whatever so that I can test these things all in JavaScript as I'm building out my solution. Okay? All right, so again, React.render component, it takes two arguments. The first one is the actual makeup of the component itself, and then the second one is where do we mount this component into the DOM, right? So we saw that in both these examples. The first component, or the first argument is what does the component look like, what does it actually look like, and the second one is where do we want to mount this into the DOM. All right, so let's get back to where we were, and let's talk a little bit about the different types of components. Right, so I've already talked about this, render component, the component itself, where to attach it into the DOM. And when we want to create specific components of our own, i.e. wrap them around an object, what we do is we use React.createClass. And what this does is this creates a specific component that is now reusable. Right? And when we look at the Twitter example, the code for the Twitter example in a few minutes, you'll see that we use the same tweet class that we created, i.e. the component, to show the multiple tweet entries that we have on the screen. Okay? So if we look at the previous slide, we had React.createClass. We call this class myComponent, and then when you want to use this class and actually render it into the view, what you do is you do React.renderComponent as you saw before, and you pass in the component. You can see we're using the HTML JSX like syntax here where we say myComponent. Okay, and this is where we want to mount it into the DOM. All right, so obviously, having static components is not really that much fun, right? Because eventually, like we saw in our tweet example, we want to insert specific attributes, i.e. we want to have some kind of templating for our components. And React, of course, supports that out of the box. It's specifically known as attributes for building dynamic components. And this is what a dynamic component would look like. So if we look at this example, on the third line here, you'll see that. Let me make sure I get my arm right here on the third line, you'll see that we're doing hello, comma, and then we have curly brace this.props.name. Okay? So then when we want to use it, if we go down to the second code block, we do React.renderComponent, myComponent, and then we pass in, similar to what you would do in standard HTML, we basically just set a property or an attribute, and we say name equals Pratik, and then when this would get rendered, the name would get pulled out, it gets stuffed into the props object, or specifically the this.props object that is available inside of every React component, and we get substitution. Okay, so this is very basic templating, and it works reasonably well. If we look at the way React does templating compared to other frameworks, or let's just talk about something like Mustache or Handlebars, right? They have the ability to be able to loop over things, and they have basically a very expressive templating language. Okay, React doesn't have that, right? But you don't need it. The way that you approach a component in React is you work at the component level itself, and you don't do you just do basic templating inside the component. You don't do elaborate templating. That's done at a higher level and not within the component itself, right? When we look at the Twitter example in a little bit more detail, you'll see what I mean in terms of how those things get rendered, right? Or when you have multiple components of the same type. All right, so we have a basic component so far, and we've seen how we can do some basic templating with it. Let's talk about the component specifications. Now, there are a bunch of different things that are available in terms of both the specification and hooking into the life cycle of a component. So in terms of the spec itself, there's something called get initial state, get default props. There's also the ability to do mix-ins to have shared state, or sorry, to have shared state listeners and other types of event listeners that you can share across multiple components. Because at some point, you're not going to write the same code over and over. Your components will share some specific attributes or they'll share some kind of behavior. So that's what the mix-ins is for. All right, so again, mix-ins are for sharing common life cycles, type of things that have cross-cutting concerns. That's what we typically use them for. So what does something like this look like? Right? And of course, I've devolved here to a log example, but if we look at this, what we do is we create a simple JavaScript object called log mixin. Right? It has one specific lifecycle event in it. We could have more, obviously, right, just by putting comma at the end of each one. But specifically, we've created component did mount, and we're just doing a log in this case. Right? And the way that we would use this mixin is we would say, if you look at the second block here, we say var component2 equals React create class, and then we say these are the mix-ins that we want to mix in with the base component that we're creating here. All right, so there are a bunch of lifecycle hook points which are useful when doing various things. The component will render is something that gets fired before the component actually gets rendered onto the view. The component did mount, you can probably guess what that does. When that component is materialized and pushed into the DOM, that specific callback is fired. And then when something is pulled off of the DOM, you can hook into the component will unmount lifecycle callback to do whatever you need to do. All right. So the other thing about React that's interesting is that components have state. So, and that's where a lot of the programming that you'll do will be around managing the state of your specific components. So what does the state look like? So again, we're hooking into the get initial state callback for this specific component, and we're just saying return a state of count equals 5, or count is 5. And then what we can do is we can access that state from within the render function, or actually anywhere within our component, by doing this.state.whatever. So in this case, you can see how I've glued the count that I set in the get initial state into the actual render part of it. So what we could do is we could set up a counter so that every time something gets rendered, we can increment it and then we can show it if we want to, right? Okay. So the other thing that's important to understand about React is, so far we've been talking about wrapping components. Okay? So we have components, we're creating them not directly, but we have to use React's create component, we have to do React.render component to be able to materialize it in the DOM. And that indirection is necessary so that React can take whatever you're trying to do, push it into the virtual DOM first, do its magic, and then push it actually into the real DOM. So along with essentially having DOM elements, you also need to have some way of intercepting events. So React intercepts events in a specific way, right? Obviously, you have to make sure you use their interceptors properly so that it can manage the state of the DOM as events flow in from the user or from somewhere else. So there's a specific class called synthetic event, but what the DOM what the React event wrappers do is basically they provide a cross-browser wrapper for all the events that you have in a web browser. Okay? And essentially what they do is they wrap native events. And it's very important that you, when you're creating a React application, that you use the native events, not use the native events, and you use their wrapper events so that React can do its work. So if we have a look at this quickly, what does this look like? Right. So you can see that in this case, we have this increment count here, and we're going and setting the state against it. So we'll look at a couple more examples once we get into the actual Twitter code on the events that we capture and essentially route through React rather than routing them directly into what we're trying to accomplish. All right. So This is the second part of it. If you remember the first part, we have this increment count function. It's just a random function that we just have in this specific component called counter. But if we look at how that hooks in, you'll see what we do is we say button type equals button, and then we say on click this dot increment count, right? So we're calling the thing that we had on the previous slide, right? But because we're writing this in JSX, what React does for us automatically is it maps this on-click event into the React framework rather than doing a direct on-click that may affect something in the browser. It's essentially intercepting that call and then storing the event state and the state of the DOM inside its virtual DOM, and then from there it will go and make whatever changes it needs to the DOM and apply them. Okay? So you don't really necessarily have to do anything special. You just have to make sure that events that you set, event callbacks that you set are done either in the component or in a very specific way so that React is the gateway into actually what happens with the event. So one thing to note is that when you're working with React, the most straightforward way to make an actual change that appears in the web browser UI is to set the state. Okay, so when we call this.setState within a React component, it basically pushes React to go and do its work to check the virtual DOM, check the actual DOM. Components will get recreated if necessary or changed, and then those changes will be put into the virtual DOM and then applied into the actual DOM and then materialized in the view. So if we go back to this previous slide, you'll see that what we're doing here at the top right under increment count is we do this.state. Count is this state plus 1, right? And what this does is when we call this.setState, it will actually go and the component will get re-rendered at that point, essentially. Okay? Obviously, there's a few things that happen in between. The virtual DOM will get updated, some diffing will happen, batch updates, and then applied to the DOM, right? All those little steps in the middle, but you don't have to worry about that because React takes care of that for you. All you have to do is change the state of the component, and that essentially leads you to a re-rendering of that specific component. All right. So we've already talked about set state. Let's go talk about the Twitter stream example for a few minutes, and we'll be able to have a better look at what we're doing. Again, this is the example. So you can see since I started talking 25 minutes ago, we've had 79 new tweets mentioning DevOps. So if I click this button, you'll see that it comes in pretty quickly. So it just inserted 79 of these little tweet components into our web page. Okay? And hopefully there's nothing on this Twitter stream that is bad. But if we go look at this, we can also open this up in Firefox. And of course, everything is broken now for some reason. Let's see what happened. Let's restart our app. I'm running this in non-production mode. So it's actually a little slower than it should be, but that's fine. There we go. But you can see how quickly it loaded those tweets, right? If I scroll down, you'll see, I think it loaded about 20 of them. And then if I click this, you'll see it instantly pops in, right? We have some animation, obviously, that we're doing as well. So we're not just literally sticking in the tweet into the view. What we're doing is we're saying, okay, here's a tweet, and then animate it in, right? So we're actually doing something quite complex. And so if I hit that again, you'll see that it basically updated and inserted it into the stream for us. All right, so let's go look at some code. And where I want to start is I want to start with the top level component, which is essentially the entire web page, and then work down to the tweet. Okay, so this is our tweets app. If we look at this example, you'll see that this is coded using standard Node.js style, so that's where we have the require. So this is what runs on the server, but I'll talk about browserify in a few minutes. So if we go look at the actual tweets, you'll see that we're still using the require keyword here, right? But what's actually happening is that we're using browserify, so it will take this Node.js component and clean it up and get it ready so that it can be shipped over to the web browser, okay? But we'll get to that in a minute. Let's talk about the top level app first. So you can see what we do is we have tweets.react.js. This is our tweets component, and then we have our notification bar.react.js. So if we go back here, that's this thing right here. All right, let's go ahead and click that. All right, and so inside of this, we have our React create class, and there's a bunch of functions in here. I don't want to talk about every one of them. I just want to highlight some of the things that we've already talked about so far. All right, so let's go to the bottom. And you can see here's our render function right here. And this is specifically using JSX. So you can see that we have a div, class name equals this, and then we have our tweets sub-element, which will contain a collection of tweets inside of it. And then we have our notification bar. And again, you can see we're using that this.state.count to give us the count of the number of tweets that show up, and that's this number right here. So if I zoom in, you'll see it says there's 6 new tweets now. Okay, that's essentially what we're doing is we're passing the state passing and storing the state using this.state.count. Okay, and I'll talk about the rest of the app in just a second. Essentially, we're using a socket I/O connection back to our node server. So as tweets come in on our node server, it pushes out over socket I/O, and the app receives it. And it updates the notification bar as new tweets start coming in. All right, so this is our basic render. You can see we just have a div here. And if we go into, well, we can talk about the socket.io a little bit. You can see we have our socket I/O set up here, and we do socket on when a tweet event or a tweet data comes in over socket.io. It does self.addTweet, and the self.addTweet essentially adds it into the state. You can see we do this.state. Here's all the tweets. This updated contains the new tweets as they come in. We update the count, and we update whether they should be skipped or not, et cetera, et cetera. A few other things, okay? But so you can see how we're working with this. Is we create the component, and we think about how we create our web application by thinking of the web application in terms of state. Right? We don't necessarily think of it in terms of, well, this tweet just came in, so I need to create this DOM element which has, a LI or something and blah, 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 right? And needs to have a picture and stuff like that. We shift the way that we think, where we offload the actual low-level construction of the HTML down into a React component, and then we think about how we're going to change the UI by thinking in terms of how are we going to manage the state of the user interface, rather than what the UI actually looks like. Okay? So when a tweet comes in, for example, what happens is we set this state, and when we fire this .set state, if you remember what I said a few minutes ago, whenever we set the state, it forces a re-render. Okay? And we're at the very top here. So we haven't even dug into the tweets collection, right, which would be very kind of simply, it would be this like column, if you will, this entire column, and then we have a tweets component, right? But what we're doing is at the very top, we're setting the state. So what happens is for any subcomponents that are within this specific React component, again, this is our top level component, React.createClass. You can see that we have some subcomponents contained within it, specifically that tweets column and the notification bar. Okay? So when we set the state on it, it forces everything to essentially go wake up and re-render. You might think that's slow, but JavaScript is actually very, very fast when you're not doing something in the DOM. Right? When you're going and just updating objects, and you fire some JavaScript, React fires up its JavaScript code for managing the virtual DOM, and then managing the state in the virtual DOM, and looking and diffing everything. You might think doing all that is really slow, but it's actually very, very fast, because typically in a web browser, the slowest operations are things when you actually go and manipulate the user interface, i.e. when you manipulate the DOM. When you're just working in JavaScript in the background, it's actually very fast, just as a baseline. Okay? So, and I know this is a Java conference, so one of the things I like to tell folks is that for example, the Chrome JavaScript runtime, which is called V8, actually is getting to a point now where it rivals the JVM in terms of pure performance. Okay, you may think, wow, that's crazy. JavaScript is a scripted language, and it has dynamic types. It doesn't have static types. How can a scripting language, virtual machine, i.e. V8, rivals something like the JVM, which has, because of static typing and other structure in the language, it can optimize code and look forward in the JVM in terms of the JIT and everything. But V8 is actually very, very fast. And so are the other modern JavaScript engines, SpiderMonkey and Nitro, that run respectively in Firefox and in Safari. Okay? So we don't worry about the fact, at least for this application, that we are initiating a change in the state at the very top, and it's going to propagate. That change in state is going to cause all these sub-objects to come alive and, oh, do I need to change, and blah, 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 right? We don't worry about that because, again, JavaScript is very fast, and modern web browsers with modern JavaScript engines can handle the non-UI JavaScript stuff execution in a very, very fast way. All right. So if we go look at where else we're calling set state in here, you can see we also call it a couple of different places. So the other place is when we loaded page tweets. So this is when I come into here and I scroll down, and let's go back to here. It's a little bit easier to see this. All right, so when I go down, we have a lot of tweets coming in. All right, so when we hit the bottom, you'll see, watch very closely, when I hit the bottom, there'll be like a little animation for loading, and right there. And then you can see, boom, it loads more tweets. Okay, so again, our other hook into loading more tweets is this load page tweets function. And if we go look where this is called, again, this is called from a specific XHR call that we make to the back end to say the user wants to hit the infinite scroll and load more tweets. So when we hit this get page function, we have a specific listener at the bottom of the page in the scroll event. So when we hit that, it will call that load page tweets. It'll make a call, grab the tweet data, and then render a whole bunch of React components and stick them at the end of that big list that we had. Right? And if you're interested in how those, what that specific function is, let me see if I can find it. All right, so we have this check window scroll function, and what all this is doing is that it's checking that we've hit the bottom of the web page, and when we have hit the bottom, it goes and it fires off that get page, which goes and loads more tweets, etc. Okay. So, anyways, we've talked quite a bit about this. There's nothing too crazy in here. You can see one of the things I've done here is that I have this get initial state here, where we go and set the initial state for that. In this case, because we're at the very top of our component hierarchy, for the entire page. All right. So, and you can see we have component did mount here. This is where we go and we set up our socket IO connection to receive asynchronously tweet data over a socket IO connection, right? Basically over a WebSocket, right? But you can see that this is one of the many uses for component did mount. You can set up some initialization that you want to run after the component has been materialized into the view. All right. All right. So let's go look at our tweets object. This one is actually very small. You can see there's not much to it. If we look at what's actually being returned from our render function, you see we just create an outer layer, which is a UL, unordered list, and then inside of that is the actual tweets. Right? Again, so I told you this wasn't very fancy. We actually go look at the tweet component. This again is not too crazy, but you can see that we had a UL on the outside, which was our tweets component, and now this is our tweet component, i.e. each individual tweet. And you can see that we have an LI here that essentially wraps the entire tweet, and we have some styling in here, et cetera, et cetera. And you can see this is where we're actually pulling out the tweet data. We do tweet.body, and then we insert that, and then tweet.screen name, obviously, for the person who sent that tweet, et cetera. Right? So pretty straightforward. And this is where we grab the avatar with the image source tag. Right, so this is relatively straightforward. So how are we tying this together? Right? Well, we're going to get into the isomorphic part of it now. So if we go and look at how this is tied together, let's go pull up our routes.js. And again, this is a Node.js based application. What I want to do in this demo is I want to demonstrate using React in the browser, and then using React components on the server to essentially create HTML that you can then send up to the browser if you want. Okay? But if we look at this, you'll see this is the interesting part of it. We hit it right at the top. So we're in the routes right now. When we go to the slash, or basically the index of our little web application. If you remember where we were at, let's see if I take this off. When we hit this, we essentially have a route set up where the index function drops us into here. So what we do is we go get the tweets, right? We have a model on this side as well. We can talk about the model object, but that's not what we're really here for. So I'm not going to get into too much detail on that. But you can see what we've done here. If I highlight that, you'll see here's my tweets app. Again, this is my main React component. Okay, this is the entire web page, basically. What I actually do is in this tweets app, that is my React component that we were just looking at a second ago. And this res.render that's basically Node.js for go and send this up to the browser. Okay, or essentially response.render, send this up to the browser. And you can see what we're doing is we actually use React.render component to string, because obviously there's no DOM on the server. You only have the DOM in the browser, right? But what we can do is we can create that React component, and then on the server we can say, you know what, I don't want to render it in the browser. I want to actually render it here on the server. So what this will do is this will take the tweets app component. Right? It only takes one argument, which is the actual React component you want to render, React.render component. And it says, here's the tweets app, here's all the tweets that should be rendered inside of that main tweets app component that we have, right? And then we step from the main tweets app down to the tweets and then down to the tweet itself. And we say, okay, render that component to a string. Here's our markup, i.e. this is the actual generated HTML. And we take right there our markup and we just plug it in. We're specifically in this case, we have a little bit of templating going on. If we go look at home real quick, right, just using handlebars, but again, this is nothing really very fancy. You can see here's markup. This is just some additional HTML wrapping that we needed to do to be able to have proper markup for mounting our component into the overall web page. Okay, so we basically render component to string on the server. It goes and creates all the markup that represents that component and all subcomponents underneath it. And we push that to the browser, and that's what we get when we hit the initial view. So when I hit the reload here, what this is actually doing is this is actually invoking, since I'm at slash right now, this is actually invoking this specific block of code, i.e. the index. We go and get the tweets, render the component to a string, and then we go and push that up to the browser. We say, you wanted index, here's what index should be. Okay? So let's have a look at a couple more things while we're here. One thing I want to talk about just very quickly is if we have a look at our package.json, one of the things that we're doing in terms of working with these React components is we're using something called Browserify. How many folks have not heard of Browserify? Okay, so there are a few folks. I'll spend a couple of minutes talking about it for those who haven't. Essentially what Browserify lets you do is when you're in your code, in this specific example, let's go and look at the actual tweet.react.js. You can see what we've done is we've written this in standard Node.js style where we are creating a node module. Okay, so you can see we have module.exports here, and we have var react equals require react. Both of these things, the require and exports, is not something that's available in the browser today. Right? What Browserify does is it takes these things and says, oh, you want to ship this up to you want to take this Node.js style code and you want to run it in the web browser. Well, Browserify will take this and convert it into essentially a module that works in the web browser. Okay, so it takes your Node.js server-side code and transforms it a little bit so that it works in the web browser. Right? So it essentially strips the module.exports and strips the require and bundles everything together, et cetera, et cetera. It's one of the first steps in packaging when you're creating one of these isomorphic style applications. Or even if you're not creating an isomorphic application, you can use Browserify to write JavaScript code like this, and it'll manage the changing or transformation of the JavaScript from Node.js style into browser style. Okay? All right, so we don't really have much else here. One One thing I do want to talk about quickly is something we haven't looked at is the notification bar. Right? So you can see, again, what we have is notification bar equals react.createClass, and this is where we're keeping our counter. Right? So here we have this.props.count. And again, if you remember the sample application, that counter is this thing right here. It's this, well, now the number is 16. Okay? So if we go look at what this is actually doing, you can see we have our div bar, we give it a class name, that's how we apply the stylings. Obviously there's a CSS file here where we have all the stylings for all the various different things. Here's the notification bar, for example, when it's active, top is 0 and the color's white, you know, et cetera, et cetera. Okay. And we have our markup. Again, in this case we're using JSX to essentially directly create HTML-like markup inside of our React component. But the interesting part here is we have this onClick equals this.props.onShowNewTweets. So what this does is essentially it triggers inside of React, it triggers a specific location where, oops, that was weird. It triggers a specific type of thing. So we've changed the properties and we need to apply them. And when we go look at what we've done here, you see we're firing on show new tweets here, and this essentially goes and fires show new tweets. And we go look at that, you can see what this does is essentially it goes and gets the state and it does a bunch of stuff. So even though we rendered this component initially, and right now I'm back to the tweets app component, even though initially we rendered this component on the server, remember when we were looking at the routes.js right here, if you remember this little fragment, we did render component to string for tweets app. So we rendered this on the server initially, and then we pushed the rendered content up into the browser so the browser would instantly be able to show it. But when we're actually running this code in the browser, so this tweets app component that we have here, it actually is also running now in the browser. So we didn't just use it to render something once on the server and then push it up to the browser. We render it on the server, and it actually becomes live in the browser as well. So when we hit this notification, click here to see new tweets, it goes into, let's just trace back. Right, so this is in our notification object. You can see we have this onClick, this.props on show new tweets. That takes us back to our tweets app, .react.js, and as we saw, this is where our show new tweets eventually, that when somebody clicks it, that's eventually where we end up. Okay, so this code, we use it to generate this specific component. We generate the initial bootstrap and the entire view on the server. We push it up to the browser. It gets shown, but it also becomes alive in the browser. Okay, so we're doing true isomorphic stuff here where we use the same component both on the server and on the browser itself. All right, so you see this is where the hook was on show new tweets. We had show new tweets, it takes us to this. This does, again, to change the user interface to have those new tweets, we do a this.setState, we say here's the new tweets, and off we go. It goes and it actually runs in the browser at this point. Okay, it's not running on the server at all. All right. So I think we've covered everything that's interesting in terms of the actual low-level code. For this example, it's just using a MongoDB database to store tweets so that when somebody hits the page first time, it's not completely empty. It stores all the tweets that we've had since we've been running the application, so it can have a database just to go pull them from. Right. So I'm not going to get into Mongo and Mongoose right now. That could be a separate discussion altogether. All right. So talked about a few things. Right. We talked about Browserify. I'm using Socket.io here to do the asynchronous WebSocket connection from the Node.js server. As new tweets come in, it puts them into the database, and it fires off to any connected WebSocket saying, there's a new tweet, there's a new tweet, there's a new tweet. And in the background, we just collect those tweets until the user clicks the update new tweets button. Okay? already showed combination browser-server rendering. So if we look, again, this is our component. You can see we used React.create class to create our components, and that was essentially our main component. Again, we've kind of covered some of this stuff already in our code. This is our tweet class. Let's spend a couple more minutes talking about isomorphic. Right? So you saw that we use Browserify to be able to take this code and change it so that it would go up onto the server, but we use specifically on the server React.render component to actually render our component and then push it up. Right? So what we were doing is we generated the initial page on the server using render component to string, and then when new data came in, we rendered that on the browser itself, and we also got the infinite scroll on the browser by essentially changing it in the browser itself. Right? So in the browser, our tweets app component ran just as we expected, specifically to show new tweets, is something that we ran on the server initially, and we also ran on the browser. All right? And again, you have to remember that setState invokes render for all components and all subcomponents. And again, just to reiterate the point, when you call this, right, and we call this from the very top, so from the tweets app to the tweets list to the tweet itself. So, and you would think that this would be really heavy, but actually Facebook's React is smart about how it manages that, so it actually is not a very heavy operation. I'm not saying that you should always keep your state at the very, very top level, right? You actually want to keep state where it's appropriate. We may want to keep state all the way down at the tweet level, which we do, or we may just want to keep it in the list, right? Depending on what kind of app you're doing. You may have multiple places where you're setting the state to force just a reflow of that specific subcomponent and its children. All right, so again, it's not slow because we don't need to worry about affecting a lot of change. The virtual DOM encapsulates the different changes and does the batched updates and everything like that, right? So again, we rely very heavily on these things. We don't necessarily have to do anything special as long as we follow the React component model to be able to get these cool features, right? Virtual DOM, smart diffing of the DOM, batch DOM updates, etc. So we had a quick look at the server as well, right? Render component string. I'm not going to talk about that again. I purposely kept this a little short because I find that you get much better reviews if you let people out early for lunch, right? So happy to entertain some questions for a few minutes, but lunch is probably being served, so if you want to go get lunch, you can do that. But I'm happy to take some questions until time runs out. Good. So questions? Anybody? I can't see. So everything was clear as mud. Yes, sir. Go ahead.
How does it play with the custom elements, for example, polymer and things like that?
Okay, so this is an excellent question. The question was, so how does it play with Polymer and web components and other things like that? So the way that I think about it is React it can be one implementation of something that follows the Polymer and material design kind of overall framework, because the Polymer and material design are more like a set of guidelines that also have an implementation. That's kind of the longer answer. The short answer is I don't think we're exactly sure yet how that's going to play out, because Polymer and material design and web components, all the Google stuff, is all relatively new. So the short answer is I don't think we know yet as a community how that's going to evolve at this point. Okay. More questions? Anybody else? Everyone just wants to go to lunch? I understand that. All right. Thank you for coming, everyone. I hope you enjoyed the session.